Today we are going to talk about finding the area of an object with fractional side lengths. Here are some helpful definitions. Please copy these down in your math journal. The area is the number of square units needed to cover a surface. So, you may remember talking about the perimeter of an object. A perimeter is, if you watch my blue line, would be as if you walked around the outside of an object. The area of an object is the number of square units needed to cover the surface of the object. These are labeled in units squared. So what this means is it could literally be square units. It could be centimeters squared, inches squared, feet squared, yards squared, and these are just some of the many examples that you could see. But there are many, many more. And the reason for that is when you find the area of something, what you're doing is you're multiplying the length times the width. So for example, if this was 2 centimeters squared and this was 5 centimeters, oops, not centimeters squared, I'm sorry. This was 2 centimeters and this was 5 centimeters. What we're doing is we are taking, to find the area, we are taking 2 centimeters times 5 centimeters. Now, when we do that, we have 10, but the reason it's squared is because we're actually taking this centimeter and multiplying it by this centimeter. This gives us centimeters squared. Here's our first example. Holly wanted to find the area of her doll's tabletop to make a tablecloth. What is the area of the tabletop? So again, when we're looking for area, we're looking for what it would take to cover the object, just like this tablecloth is going to cover the tabletop. So, let's get it here. What we need to do to find area is multiply the length times the width. So what I'm going to do here is I'm going to take the length of the tablecloth, which could be 3/4. I'm going to multiply it by the width, which would be 1/2. Now, it doesn't matter which one you decide as the length and the width, because when we're multiplying two numbers together, as long as it's all multiplication, it doesn't matter which order it's in. So if you have 1/2 times 3/4, you're still fine. So now I'm going to use what I know about multiplication. I'm going to look to my diagonals to see if I could cross cancel anything. 3 and 2 have no factors in common. 1 and 4 have no factors in common. So I can multiply. 3 times 1 is 3. 4 times 2 is 8. So I get 3/8. Now, I want to make sure that I properly label my answer and make sure it's in simplest form. So I know that I'm 3/8. They have no other factors in common, so besides 1. So it's in simplest form. I look for my unit of measure, which is feet, and I make sure that I square it. Very, very important. So my final answer, the area of the tabletop, is 3/8 of a foot squared. Here's our second example. Josh drew a rectangle in his industrial drawing class. He wants to find the area of the rectangle by tiling it with unit squares. So just to stop us here, when it means unit squares, what it means is when we see the examples with 1 unit square inside of there. So if we just do maybe up here a little key for us, this equals 1 unit square. Okay? The question asked is, what is the appropriate side length for 1 unit square to tile Josh's rectangle to find the area? So here it's not asking you to find the area of Josh's rectangle, it's asking what the appropriate side length for 1 unit square would be. Now since it's a square, all side lengths are going to be the same, so the answer would be the same for all. So here's how we're going to find out what this would be broken up in unit squares. We're going to use something that kind of relates to when we were modeling before. So here, this is 5/8. So if we were going to break this up into units, okay, and that, I'm going to draw that one more time because I feel like those are not equally sized. You want to try your best. On a perfect world, these would be perfectly the same size. Okay, so each of these represents a side length of 1/8. Now it's very hard to see with my stylus since it's pretty thick here, but each of these, I'll draw an arrow, okay, whoops. One side, so in the red here, okay, this would represent 1/8 because the whole side is 5/8 and, oh wait, no, I'm so glad I said that. I want this partition in 8 equal sized pieces because of my denominator. Much better. Okay. So use my mistake here to be a common misconception that you do not do the same. So we want to partition these into eighths. That's what my denominator tells me. So one side here would be 1/8. Now, if you're thinking about squares, you know that if that's one side of it, they're all going to be the same. But I'm going to show you to make sure so that it looks like the unit square we show up here. So now I'm going to take this again. This says eighths, so I'm going to partition this side into eighths also. If it was fifths or halves or something along those lines, then you would partition it depending on what the denominator told you. So now we're going to partition this into 8 equal sized pieces. Or try to partition in 8 equal sized pieces. So now if I look at this side, this now represents 1/8. So each unit square is 1/8 by 1/8. So in this case, when it asks what is the appropriate side length for 1 unit square, the appropriate side length would be 1/8. Now, sometimes, for example, in this one, they both have a side length of 1/8. But depending on what the area of both sides will depend on the unit length. So again, what is the appropriate side length? It'd be 1/8 and then the appropriate label. Now here, it's not asking you for the area, so it's not going to be squared, it's just going to be regular. Now, pause the video and see if you can solve this problem on your own. Okay, the problem says Jessica wants to buy a canvas to paint her favorite flower. The canvas is 1 1/2 feet long and 3 feet wide. What is the area of Jessica's canvas? Represent your thinking with a rectangular model and an equation. So when it says a rectangular model, what it all wants you to show is what her canvas would look like. So if it is 3/4 feet wide and 1 1/2 foot long. So there's our rectangular model. We're good there. Now we're going to show our equation. So to find the area of this canvas, we would do 3/4 times 1 1/2. Here is our equation. We're good there. Okay, but now I need to solve. So I remember what I know about multiplication. So I have to find here, I have 3/4. I have to change 1 1/2 into an improper fraction. So to do that, I need to multiply my denominator times the number of wholes I have. 2 times 1 is 2, and then add the numerator 3, and my denominator stays the same. Now I'm going to look and see if I can do any cross-canceling. 3 and 2 have no common factors besides 1, and 3 and 4, so now I can multiply. So if I do that, 3 times 3 in my numerator is 9, and 4 times 2 in my denominator is 8. I need to put that into simplest form. That means change this improper fraction to a mixed number. 8 goes into 9 1 whole times with 1 left over. And I will get 1 1/8. Now, I'm not done yet. I need to make sure I do the appropriate label. My label is feet, and since I'm doing area, it's going to be feet squared. So the total area of the canvas is 1 1/8 feet squared.